NASA's newest launch, the James Webb Space Telescope, was recently involved in a collision with a mysterious object in space. Accidents in outer space. It's one thing to talk about collisions on roads, but to hear about them in orbits in space is quite another. So, what is this mysterious object? Has the JWST been too gravely damaged to continue with its mission? Will NASA continue to receive data from the JWST? Or will billions of dollars be spent, yet again, in repairs? The only place to begin a story is right at the very beginning. You might wonder what the need to keep sending up various kind of space telescopes decade after decade is. They all stay within orbits and take pictures of an endless and dark vacuum. But to us, this is a rather dreary definition of space, so let's ask the first question. Why was the JWST sent out to space in the first place? Unlike the Hubble Space Telescope that orbits the Earth, the JWST, on its mission around the Sun, is tasked with the collecting of data and images about various galaxies outside our solar system. The purpose of the telescope is to answer the age-old question of what is truly out there in the beyond. The official NASA website for the JWST also mentions that they hope to collect information on newly forming stars and galaxies by peering into dust clouds. Other than the obvious difference in distance from the Earth, the JWST and Hubble Space Telescope also differ in their make and their technological capacities. Imagine two cars. One is revolutionary because it is among the first to be made. But the second, although 30 years newer, is faster, can go longer, and is sleeker with a cooler stereo. The JWST is faster than Hubble, can go further back in time to collect previously inaccessible data, and has a much more advanced communication system. It is NASA's shiny new toy. The telescope has two particular features that make it stand miles apart from most other space tech. This is where things get interesting. For NASA confirms that the JWST includes a large 18-part mirror and the ability to detect infrared wavelengths of light. Infrared is known to travel longer than ultraviolet, thus meaning any infrared light detected by the telescope will have come from farther away, and perhaps even so in terms of time. This will mean that the data revealed by this kind of light will tell us about more far away and older places in the universe. The 18-part mirror helps collect a larger amount of this infrared light due to its larger surface area. This allows more data to be collected in a shorter span of time. While the Hubble was all the rage when it was first launched, it does not compare to the JWST, for it has a smaller mirror surface area and is enabled to detect ultraviolet wavelengths of light which are shorter than infrared. They are each programmed to collect different sets of data, both incredibly useful to understanding and mapping the universe as we see it. It was the 25th of December 2021. On Christmas Day, the JWST was safely aboard the Ariane 5 launch rocket, ready to set off on its maiden mission. But little did the world outside the scientific community know how record-breaking the JWST truly is. It is not the first space telescope to be sent out, neither was its launch one for the books. But NASA's JWST is the first and only space telescope to be in an active orbit around the Sun. Here we pose two questions. On most days, when we cannot stand the heat of the Sun all the way here on Earth, how is a telescope that is much closer to the Sun not already burned to a crisp? And how does the telescope, which is much smaller when compared to the other planets and celestial bodies, continue to remain within the same orbit without being pulled or pushed by other gravitational fields? Scientists at NASA report that the telescope is protected by a large sun shield. To answer the second, we might need to get a little technical. Our school science books have long told us that the larger the mass of an object, the greater its gravitational force. It is only natural that you will be dragged towards either one of these objects based on their gravitational fields, as scientists theorize to send artificial satellites and telescopes to space. They were also posed with the same question. How do we get them to stay still? They did not have to look too far, for way back in 1772, French mathematician Joseph-Louis Lagrange posed what is called the three-body problem. He theorized that when two bodies are a lot bigger than the third, there exists a certain position where the gravitational pull of those two large bodies interact in a manner that allows the third and smaller body to remain parked. Such positions in space are called Lagrange points and have been cleverly nicknamed parking spots by scientists. The JWST was sent to one such Lagrange point, L2, 1.6 million kilometers away from the Earth. A journey which took nearly a month, even in a high-powered rocket. But what went wrong once the telescope reached its new home? For about 6 months after its docking, everything was smooth sailing. But on the 8th of June 2022, NASA announced that the JWST had its first rendezvous with what are called micrometeoroids. Officials at NASA have confirmed that the JWST is in working condition and its schedule will not be disturbed. Not everything that floats around in space is disastrous if bumped into. You will be glad to know that no one, so far, has found a micrometeoroid interesting enough to make a movie about. But what are micrometeoroids and why are scientists largely unbothered by them? Micrometeoroids are small particles of space dust and debris that float around in space. Often, much like random pieces of rocks will fly at a car on a mud racetrack, these particles also collide with each other and anything else in their way. They seldom do any serious damage because of their low velocity and small size. Do not breathe out your sigh of relief just yet. It is not uncommon that even these tiny particles can, over time, affect the damage and quality of data being sent back to Earth by satellites, spacecrafts, and telescopes. The particular micrometeoroid that collided with the JWST was only about 1 millimeter. That's the size of a single grain of sand. Imagine a movie being made about that. Though the JWST might look quite sizable in a lab at NASA, in outer space it is hardly a speck. This piece of technology that costs billions of dollars would mean a tremendously expensive failure if the scientists in charge did not have contingency plans in place to fix any errors or damages without disrupting the mission. How common are collisions of this kind in outer space? Did the scientists in charge of the structural integrity of the telescope expect this kind of minor trouble? According to Lee Feinberg, Webb Optical Telescope Element Manager at NASA, this is not the first time that space debris has impacted the JWST. Even in the short span of 6 months that the telescope has been at its intended position in L2, it has already suffered through 4 smaller collisions with micrometeoroids. The collision on the 8th of June was a slightly stronger one, and the micrometeoroid was bigger than they had estimated, which was why NASA officials issued a formal update. The collision caused minute structural damage to one of the mirrors on the telescope, which then caused some discrepancies in the data being sent out. But fear not, engineers at NASA are hard at work to analyze and fix the damage caused by this particular micrometeoroid. The James Webb Space Telescope is a means of getting one step closer to unraveling some of our most mysterious mysteries. The thirst to know where we've come from and the desire to study the possibility of Earth-like planets in different solar systems in different galaxies. There is, however, also a very real need to make such a discovery, for our planet is also at grave risk of being completely drained of its natural resources. So while things might not be quite as dramatic as having to relocate to another planet like the ending of Don't Look Up in 2022, there is a very real possibility that we will run out of basic resources, especially clean air and water, halfway through this century. Even if we do not find another Earth, the JWST could reveal to us the history of the universe. But for that, we'll have to wait just a little while longer, while scientists attempt to make sense of the data being transmitted back to them. Until this moment, the only images that have anything to do with the JWST are images of the telescope itself and of its position in outer space. NASA is yet to release the actual images taken by this telescope and has in fact set up a countdown page for those of us space fanatics eager to see what is in store for the world of astronomy. Once the timer hits 0, NASA will finally upload the JWST's findings and what it means for science. So, here's to waiting on the edge of our seats for the universe to unfold.